Section 5. Risk Mapping. Recall the toy example introduced in Section 3 that in the case when the portfolio consists of only two assets, we just simply treat each of the assets as a risk factor. However, in daily life, due to the typically large number of assets in the portfolio, it is very difficult to maintain volatility and correlation data for each and every asset in the portfolio. In addition, there is also the problem of obtaining a positive definite correlation matrix for a large portfolio, as well as the time efficiency problem. Therefore, here comes the idea of risk mapping. That is, assets are mapped onto benchmark assets for which the required data are collected and maintained. These benchmark assets are also called primitive assets or risk factors. Each asset in the portfolio could be mapped to one or more primitive assets. Thus, the original portfolio of asset positions is transformed into a portfolio of primitive assets. VAR is then obtained for this transformed portfolio. The aim of risk mapping is to reduce the dimension of the correlation matrix involved. The primitive assets are selected carefully in a trade-off between the desire to reduce the number of risk factors of a portfolio to manageable proportion and the inaccuracies resulted from the grouping of risk factors. The Pioneer VAR system, Risk Matrix, maps individual asset positions to a set of primitive assets for which the database tracks the volatilities and the correlations of the primitive assets. Here are some mappings used by Risk Matrix. Foreign exchange rates are usually mapped to a number of core currencies. Foreign exchange forwards are mapped to fixed income positions in respective currencies. Equity positions are usually mapped to equity indices in each of the core currencies. And fixed income positions are mapped into combinations of cash flows in a given currency of a limited number of maturities. In the following, we take a closer look at the mapping of equity and fixed income positions. Now let's first introduce the mapping of equity positions. Suppose an amount of X1 is invested in the equity of firm 1. Recall from Cap M, we have the variance of the firm's return satisfying the following equation. Assuming normality, VAR of this equity position can be obtained by multiplying the alpha of the corresponding confidence level to the volatility of the dollar return, which is given by the dollar position X1 times sigma 1. Here, beta 1 is the beta of the equity of firm 1, sigma m squared is the variance of the market portfolio, and thus beta 1 squared times sigma m squared is the systematic risk of the equity, which cannot be diversified away as long as the equity has a non-zero beta. The sigma e squared is the so-called non-systematic risk, or the firm-specific risk, and if the portfolio is well diversified, it will be negligible. Setting sigma e squared to 0, we obtain the following formula for calculating VAR of the equity of firm 1. Here, the risk factor is the market index return, and the dollar exposure to this risk factor is given by X1 times beta 1. Let's take a look at the following example. Consider a portfolio with $1 million invested in stock 1 with beta equal to 1.2 and $3 million invested in stock 2 with beta equal to 0.9. The market index has an annual volatility of 20%. Can you determine the 10-day 99% portfolio VAR? Since the portfolio consists of two stocks with $1 million and $3 million being invested in each of the stock, we first obtain the beta of the portfolio, which is equal to the weighted average of the betas of the two stocks. Then, the required VAR of this portfolio can be calculated as follows. Note that Alpha is equal to 2.326 for 99% confidence level. The market volatility given is annualized, and we assume that there are 250 business days in a year. As a summary, in this lesson, we have introduced the risk mapping for equities. We'll continue this section with risk mapping of bonds in next lesson.